Several years ago, we acquired these god-awful knockoffs of the annular booster for the Edelbrock carburetor. We measured them and they were horrible. But are they really? Well, we're going to find out today and run them on the GMC. The issue we had with these boosters is they were wildly off of the annular booster that comes in the 1906, 1905, which I will make the assumption, because we don't know, that that's what they were knocking off. But if we do that and compare these boosters to the boosters that are in the 1905, 1906, they were wildly off. So I don't really understand what it was they were trying to copy, but it's just they were so far off that we just made the determination that they're going to meter air differently. Now, when you talk about what happens in a Venturi and pressure drop underneath the booster here, getting the booster correctly placed inside the Venturi, so this pressure drop down here, it occurs with the signal that's needed to draw the fuel up through the jet, the bowl, and down through the booster and into the stream is critical. And when you modify this, meaning you change the position of where the booster is in the Venturi, and you change the diameter, the height, all of those things, inside diameter, all of those things really change how the booster flows fuel. So what we're going to do today is we're going to put these into a carburetor we'll build and just see how they work. Now, we've done that before, where we've taken boosters out of the 1906, put them into a 600 and see if it worked, and the AFR was a little off on that. So I am anticipating that we're going to have the same issue here. Potentially, we're going to find out. So I'll keep an open mind about it. We'll see what happens, but you know, all of the little details here tell me that we're going to run into some issues, especially on the install. The air bleed here on the top is certainly in an angle. It's not correct. The places where they pick up fuel is incorrect, which makes a difference in how, again, when you're talking about a pressure drop here, this here is at the static pressure or the ambient pressure that's in the air, and when it's at a regular pressure here and it's a low pressure here, it's going to feed the fuel in there to take up that space. So the problem ends up being is all of these things are critical of where it picks up fuel, how it picks up the fuel, how much air bleeds in with it. So we measured all of those, everything we could. And again, it was wildly off. So that's what we're going to run into, I think, today is potentially that challenge, but we're going to see and find out. One thing that can't be argued is the gaskets in this thing are absolutely awful. Hardware's awful. It's the same stupid screw-in type stuff. It's not a trilobular hardware, so it's not going to, mesh with the threads on a Edelbrock carburetor that are made that way. Having the stupid lock washers on there doesn't make any sense. So none of that crap we're going to use. We're just going to concentrate on the booster. So let me get a 1406 kind of put together. I don't think I have one here. I may have to build one, and then we'll go from there. Well, I found pieces to a 1406, so we're going to have to kind of piece this together a little bit. Shouldn't be that big of an issue. Everything here looks fairly serviceable. Just need to give it a really good cleaning in the ultrasonic and make sure that jets and everything work. And we'll screw in and out of there, give it a good cleaning, and we should be good to go. So let me do this. Let me spend a few hours with this thing and see if I can get it ready to be put together, and we'll kind of go from there. We're all back together. A couple of things on this 1406 to talk about. The electric choke is wired completely open. I don't want that moving around. I want it to be always wide open. We don't have to worry about that as a factor in the test. Also, too, went back with the stock rods and jets in this. So we're going to leave it alone. I'm not going to change it at all. We're going to leave the stock calibration for this 1406 in there, so we will measure the AFR that way, and then we will put in the knockoff boosters without making any rod or jet change, and we'll go from there. The only thing I'm going to do with that is I'm going to put the step-up spring in there that carburetor wants on the engine, because that will affect how the carburetor meters fuel. But as far as timing goes, but as far as the amount goes, we're going to leave that alone. Got to my spot, idling where I want to, good AFR. So again, I think what we're going to do is Since I can kind of record this on the screen like I did before, hopefully we'll see it here. If not, I'll come around the other way so there's no glare on there. But I think what I want to do is do a very mild drive. So I think what I want to do is try to keep it around 35 miles per hour-ish. And then we'll make a couple of passes, and then we'll record the AFR. Also, what I want to do is we'll do one that's kind of wide open throttle, meaning we'll do it kind of the way we do down the spot I'm at down here, where I usually tend to test that, see what happens. But I'll make a couple of passes at 35 miles per hour and kind of see where it goes. So that's going to be the test. We'll do the exact same thing with both of them and see what happens. So let's try 35 miles per hour, see what happens. I guess we'll go 38, 39. 40, I guess, seems to be the number. We'll do 40. 1406, so remember, it's going to run lean. I'll leave a link to that video where we discuss what a 1406 is. And it's not technically a performance carburetor. It's made to be metered lean. That's because of the booster. So, let's do 40. Let's call this a 40 mile per hour test. Had to change course midstream here a little bit. So the 1406 that I built was just running way too lean, and I get it. I know what that carburetor is. We've done quite a few videos on that. The 1406, the 1411, those electric choke models of the Edelbrock carburetor have a different booster in it. They don't flow the same amount of fuel. You can go back and check that video out. I'll leave a link to it so you can go look at it. But the 1406 is not considered a performance carburetor. It runs much leaner. And I knew that was going to be the case, but it's just, I wanted to make sure it wasn't the carburetor and not something that I was doing. So bought another carburetor, bought another 1406. We're going to go test drive this real quick. And then if it's still lean to a point where I'm not comfortable with it, we may do some tuning on it. I said I wasn't going to do that, but we may end up having to do that anyway, just simply because I don't want to hurt the engine at all, and having a little bit more fuel, and there's not a bad thing. So let me go take it for a quick spin, see what the AFR looks like, and then we'll make a decision if we'll do a little bit of tuning on it, and then we'll take some official measurements on that carburetor and leave everything as is once we're done with it. And then we'll switch over to the Chinese boosters and see what happens. But let me go test drive this real quick. Okay, we got a good reading at 40 miles per hour. I kind of know where it's at. We're showing a little rich right now, but it'll fluctuate back and forth. So I got the data that I needed. I think this changing that new 1406 is a better idea. I'm gonna have to go back through that other one, kind of see what happened with it. But yeah, let's get her back to the shop. We'll throw the Chinese boosters in it, and we will see what it looks like. So let's go get it done. It's definitely on the lean side. Not much, but that's what that 1406 is designed to do, is to be very much an economy style carburetor. It's not a performance carburetor. Got the Chinese boosters in there. Now I did have to tweak these air vents. I don't know if you can see that or not. I thought I did a little bit. You can see a little bit of them on either the video that we did on these or here earlier. I can't remember, but that it's bent over and back, or bent over and forward, and I've had to tweak it a little bit. I've had to be very careful because these are just press fit in there. They're not You know, they're not cast into there, so you have to be very careful. You don't want them to come loose. It needs that air to properly meter the fuel through there. So I think I've tweaked it a little bit. I'm about as much as I want to be. So now that we got all that done, taken care of, let's put it back together and go take it for a spin. I've been driving this thing now for about maybe 20 minutes or so, and it is definitely weird, that's for sure. So a couple of things here that are of interest. I didn't touch idle mixture, idle speed, nothing. I just literally dropped those boosters in and changed it. So our idle AFR is much richer. Now, we'll have to go through this, I think, in another video, because I don't think I've discussed this at length, but how the idle fuel fuels the port where the fuel comes out, goes through the main jet, the primary main jet in the carburetor, up through the booster, and then down into the idle circuit. And there's something in this that's a little different. Maybe they've opened those up a little bit. Maybe it's drawing more signal and it's pulling more fuel. I don't know. It's something that you would have to try to tune through, and we will. But let's take it for a cruise and do our 40 mile per hour test here, and I'll show you what it looks like, and maybe we can maybe you'll see what what I was seeing as I was driving. So let's just take it to up to 40 miles per hour and see what happens. Definitely have to go back and take a look at the data to see what our average AFR was. We did a 1 minute timed deal at around 40 miles per hour on both, with the 1406 down leg or straight leg style booster that's in there, and then the these knockoff annular boosters. I'm not quite sure where to go from here. Let's go take a look at the data first, and then I think what we're going to do is I'm going to go ahead and try to tune this carburetor and see what happens with this with these annular boosters. But I can tell you right now, just by watching the AFR at 40 miles per hour, I was in a 55 mile per hour section. It was way worse. I was at 17, 18 to 1 on cruise AFR, and that's not good. Way too little fuel, way too lean. So let me do that. Let's get back, let's crunch the data. We'll go over that, and then let's see if we can tune this, and we'll kind of go from there. One other little detail I guess I didn't mention in that is it does have quite a bit of a lean stumble to it, which makes sense. The AFR is telling us it's lean, so it kind of stutters a little bit as it's trying to look for fuel. So it's something we'll try to tune out of there for sure. It's going to be interesting because we have to watch the vacuum gauge a little bit more aggressively, see where we're at, so we can look at the step-up spring, and then we'll kind of go from there. But it's definitely strange for sure. It could be that the annular is just asking for more fuel, or back to the way that carburetor was set up from Edelbrock, the reason why they don't produce a 600 annular booster and reason they had to go to the 650 is they just need a little bit more volume going through there to give the annular booster the pressure it needs to feed fuel. So let's take it up to 50 miles per hour here, and I'll show you what that looks like. See how lean we are? Great for fuel economy, bad for pistons and valves. I almost forgot our most important test. Will it do a burnout? Let's find out. Oh, boy, I did not like that. It took off okay, but it fell flat on its face as it was trying to shift through gears. Wow. All right, well, AFR tells us how bad that was. Dang. Ugly. Ugly, ugly, ugly. right, let's get back and look at some data. All right, I've got all the numbers here, but one thing that was interesting is I was going back through there. Like I said, I did these for a full minute of 40 miles per hour, no load, really light on the throttle. Didn't have to, wasn't having to make a lot of throttle adjustments to stay there. I wanted it very flat, very sustained. Engine wasn't lugging. It wasn't going uphill 40 miles per hour. Wasn't going downhill 40 miles per hour. I just wanted to be a very, very consistent. The interesting thing that I noticed when I was doing it or looking at the data with the Chinese booster is how erratic it was. Bouncing. AFR bounced a lot, and it was certainly much leaner. I've got the numbers here. I'll put them up on the screen so you can see them because nobody's going to be able to read my chicken scratch. But it was just one of the things that I thought was kind of weird about it, how much it bounced around. And I'm talking about wildly bouncing. Sometimes it would be down around 12.5, 12.9, somewhere in there. And then other times it was like 16, 17. I think the highest rating I got was like 18.1. And like I said, that is sustained throttle. That's not, any load on the engine. So it's kind of a weird deal. And I think we're starting to see a pattern here with it, but let's go tune this quick and let's see if we can figure that out, because I think that's going to be the real test. See if we can actually tune through that situation. So let me go print off the tuning chart for this carburetor, 1406, and we'll go from there. Now that we've seen the data, we can we can move forward from that. But let's try to tune this thing. Let's see if we can take out those lean conditions that we're seeing. So printed off the calibration chart. Kind of stuck on this one. We are so lean, and I don't want this to take 4 or 5 hours of me tuning. So again, I'm going to break my own rule here. Please don't do what I'm doing when you're going through the tuning process, but this is certainly not something that's normal, so we're definitely going to look at it abnormally. We've got to go just a hair rich on the power mode. We need to go way rich on the cruise mode. Base calibration is here. We could go to 23. That's probably not a bad starting spot, but the problem with that is I don't think that's rich enough in the cruise mode. So I'm going to go ahead and jump all the way up here to 19. Unfortunately, though, that's as far as we can go rich in the cruise mode without going into some custom calibration stuff, which again we'll discuss at a later date. But I think that's where I'm going to start, is at 18, and see what we can do. Let me go do that. Let me knock that apart, get that jet changed out of there, and yeah, we'll get it back on the road and see if we can cure some of that. Got about another 20 minutes of driving on it, something like that. I think we've fixed a lot of the issues with the cruise AFR, but I'm seeing something a little bit different. Maybe we'll see it on this little pass, but I went ahead and adjust the idle mixture a little bit, take away a little bit of fuel. It's not too bad. I could probably take a little bit more out of there at idle. We're about where we normally idle vacuum wise, so let's do another 40 mile per hour test and see what happens. Let's see if the burnout test got any better. Well, unfortunately, the answer to that question is no. No load, just holding steady. See how the AFR is bouncing all over the place? The AFR should be fairly steady when you are at a steady RPM. Now it's going to jump a little bit. You've seen enough videos that I've done here where we looked at how AFR moved, as we went through mile per hour, even holding steady at some. It's going to jump a little bit. If you're cruising at 14 or 13.5, it can jump a full half point. You know, it can go up to 14, you know, down to 13. Just kind of really depends on throttle position, load, all those things that you can't really, you know, measure without much more sophisticated equipment. But certainly it makes sense when you look at how the AFR is working and what the carburetor is doing and how the carburetor is delivering fuel. The problem we had here is the AFR was jumping so much, and I'm talking about holding steady. I've tried to find some examples. I'll try to cut in a few of those here as I was driving around. But you know, if you're cruising at 13.5, 13.9, 14.0, and you're swinging with no load up to 16, 17, down to 12, 13, that's what I call erratic. That is violently erratic, irrationally erratic. But it makes sense when we talk about how this carburetor is configured and why Edelbrock did not put annular boosters into a 600 CFM carburetor. Reason being is they needed that extra CFM to meter the fuel properly. And now I understand what they were talking about when I had those discussions with those engineers years and years and years ago of why they didn't do that. It would have been a cheaper solution for them, just make new boosters, stab them in an existing 1405, 1406 body. The reason why they didn't do that is because it needs that extra CFM to meter the fuel properly, create the pressure drop underneath the booster, and get the amount of flow that they needed out of there so it operates properly. Now, we're not talking about some hypothetical here. That's real world. We've got annular boosters in a 600. Now, these Chinese boosters, I don't know. They could operate really well in a 1905, 1906 carburetor. Eventually, maybe I'll test that. It's not really important at this time. It was really beneficial for us to see, does this work on a 1406 that you want to upgrade to annular boosters? And the answer to that question is no. And like I say, the big thing is the reason why, and it's because there's just not enough airspeed. It needs a little bit more volume and it needs a little bit more speed, plus that booster needs to be tuned for the Venturi and go in where it needs to go to get that good signal underneath the booster. There's no engineering that went into this. They just did what they did, and that's what you get. When we add a little bit more fueling and change that jet, it did help smooth out some of those lean stumbles, but they weren't gone. Those are hard to pick up. You can't hear them really well on the audio, and it's hard to look at it on the AFR and see it, but it was certainly, when it was in those lean conditions, it was bouncing around quite a bit. So did this run any better with the annular boosters? No. Could I tell that there was better low-end throttle response? No, again, because we were in such a lean condition, it was hard to, to get a good feeling of it because it just wasn't metering fuel properly. It doesn't have the capability of doing that. Now, does it start, run, drive, cruise down the road? Yes, you could do that. Is it right? Absolutely not. And I don't know about you, but I would rather have my stuff running really well, driving good, start good, make good power. The burnout was a really good example of that. It had enough shot of fuel. We never changed that. The accelerator pump is still in the middle hole, rolling wide open throttle, and it died hard, stumbled hard. You definitely, I think you can hear that in the video. If not, I'll crank up the audio in that section so you can hear it. But yeah, it's resoundingly bad. In all honesty, I wanted this to work. I wanted to tune it to be able to say that, okay, yeah, I understand they're a knockoff piece, not the greatest, but if it was an upgrade to a 600, I wouldn't have been upset with that because the 600s aren't complicated to tune, but people have a tremendous difficulty at time with it, and maybe you could mask that a little bit if it had a good annular booster in it. The problem being is there's just not enough airflow for that to operate properly. So take it for what it's worth. Yeah, you can buy them. Sure, it will run and drive. It doesn't mean it's running and driving well. If you hook up an AFR to it, if you try to tune through all those things, it's just not going to happen. So if you got any questions on this one, don't hesitate, leave them down below. I'll be happy to answer them for you. But if you want annular boosters, just pick up the 1905 or 1906 instead of the Performer Series carburetor. One, you're getting the annular booster, but you're getting the adjustable AVS in there, which allows you to dial in the secondaries, and that's a really good upgrade. So great carburetor, the AVS2 is. It's one of the most versatile, universal, best street carburetors that I've ever worked on, and I'm certainly glad Edelbrock made all that time to investment to create that thing. Hopefully that'll put this one to rest. I'm sure there'll be some comments down there disagreeing with how I tested this, or it runs great on your application. Wonderful. Let's take a look at the AFR and let's see what it's telling us, what the engine is actually seeing, not what you're guessing it's seeing. So anyway, we'll catch you guys on the next one. We'll see you.